kids, Miss Kulkarni here. Let's continue with ionic compounds, formula writing and naming. But this time we will talk about transition metals in ionic compounds. So let's begin. Okay. Here are some examples of ionic compounds with transition elements. Just to remind you, these are the elements in D block in periodic table. So the first example is iron, and there's a Roman numeral 3 oxide. This Roman numeral gives you the charge or the oxidation number for iron. So iron is Fe, and this Roman numeral means it is positive 3 ion. Oxide is oxygen with negative 2 because of group 16. And then we do exactly same thing. We try to cancel the charges and we end up having 2 charges from iron and 3 charges from oxygen. So the formula is Fe2O3. Let's go over with one more example. This is tin 4 chloride. That means tin Sn has a charge of positive 4 and chloride is negative 1. We try to balance the charges and we end up having 4 chloride ions. So the formula is SnCl4. Let's work on the formula of 2 remaining compounds now. We have lead 4 oxide here. That means lead is Pb. The charge is positive 4 and oxide is oxygen with negative 2 charge because it's group number 16. So when we cancel the charges, we end up getting positive 4 and then negative 2 times, which means it is 1 lead and 2 iodides. How about bismuth 3 sulfide? That Roman numeral 3 tells me that bismuth has a charge of positive 3 and sulfide will be negative 2 because that's group number 16. So in order for us to cancel the charges, we need to have plus 3 2 times and negative 2 3 times. That means it will be 2 ions of bismuth and it will be 3 ions of sulfur. So it's Bi2S3. This is naming the compounds with transition metals. It's kind of similar. The only difference is we need to find out the Roman numeral which corresponds to the charge or oxidation state for that element. Let's look at the first example. We have PbCl2. Pb stands for lead and it's chlorine. The last name will be chloride. So we actually can get these 2 parts. The question of how did we get that 2 there? We know the charge on chlorine will be negative 1 and we have 2 chlorine atoms. That means they will give rise to negative 1 and negative 1, negative 2 charge. The total charge should be equal to 0, which makes the charge on lead as positive 2, and that's why the Roman numeral 2 and the compound name is lead 2 chloride. Let's take the next compound, Cu2S. Cu, which is copper, is the first name. Sulfur becomes sulfide, so that's the last name. And now how are we going to find out that Roman numeral 1 there? Sulfide ion is S-2 because it's group number 16. And then we have 2 copper ions and negative 2 charge goes to sulfide. The total equals to 0. So we work our algebra and we find out that each copper ion should be positive 1. So let's see if you can find out the answers for the last 2. I'm sure you will. So let's check your answers. SnO. Sn is tin and O is oxide. So we got tin oxide. And then when we look at oxide negative 2 charge, we find out tin is positive 2, which gives you Roman numeral 2, tin 2 oxide. And the last one is COF3. CO is cobalt and that's cobalt fluoride. And how did you find out cobalt oxidation number? We have 3 fluoride ions, so cobalt must be positive 3 and that's why it's cobalt 3 fluoride. Isn't that simple? Let's move on to write down the chemical formula for ionic compounds with polyatomic ions. So we have aluminum nitrate as an example given here Aluminum is +3. We know because it's group number 13. Nitrate is NO3 -1. Same old stuff. We have +3 needs to be cancelled with -1 charges. We end up having 3 -1, which gives you 3 nitrate groups. So that's the formula for aluminum nitrate. Ammonium phosphate. Ammonium is +1 always. And phosphate is -3, PO4 -3. So we try to cancel the charges and we end up having 3 ammonium and 1 phosphate group. So that's the formula. Next one is calcium hydroxide, and calcium is Ca +2. Hydroxide is -1. And how do the charges cancel? We need to have 2 charges with -1. That means we need to have 2 hydroxide ions. So the formula is 1 calcium and 2 hydroxide, CaOH2. How about copper 2 sulfate? This gives me copper charge. Copper is +2. Sulfate is SO4 -2. And the charges cancel just simply +2 - 2 = 0. That means we only have 1 ion each. So it's CuSO4. So can you work on the last one now and check the answer? So there you go. Zinc is +2. ClO3 -1 is chlorate. And then when we cancel charges, we end up having 2 chlorate ions. So the formula is ZnClO3 twice. So I guess that was simple. Well, I hope you guys enjoyed the video. I will see you again in next video. Until then, bye-bye.